If you've ever wondered what true mechanical madness looks like, forget sci-fi. Reality already has machines that operate so far past human limits they might as well come with a warning label. These aren't prototypes. These aren't concepts. These are real industrial monsters doing physics-defying things every day while the rest of the world barely notices. Let's start underground, where the largest tunnel-boring machines chew through solid rock like it's warm bread. A modern TBM pushes forward with 30,000 tons of force using a rotating cutter head armed with hardened discs that smash rock into powder. These things don't drill. They grind mountains into dust. The biggest ones, like those used for China's mega-rail tunnels, stretch nearly a football field in length and operate non-stop for months. Imagine a mechanical earthworm the size of a battleship eating geology for breakfast. But underground isn't the only place where the madness lives. Inside elite industrial labs, you'll find hydraulic presses that deserve their own horror movie category. Japan's 50,000-ton press can flatten metal blocks that weigh more than a car. The US once operated the legendary Alcoa 50,000-ton press, originally built for Cold War aircraft. These presses crush titanium and aerospace alloys with forces strong enough to break entire buildings if the energy wasn't perfectly contained. When the ram comes down, it isn't machining, it's reshaping the periodic table. Shift from crushing to spinning, and you hit another mechanical limit: centrifuges. NASA's human-rated centrifuge hits 20 Gs, enough force to make your vision tunnel and your organs feel like they're migrating. But research centrifuges for materials science? Those go far beyond human survival thresholds. Some push past 100,000 Gs, creating pressures rivaling the surface of Jupiter. These machines are basically gravity generators that can rip apart anything not designed down to the atom. Now let's turn to airflow, the domain of hypersonic wind tunnels. Only a handful exist, and they simulate the conditions aircraft face at Mach 10 and beyond. The air inside hits temperatures hotter than molten lava. A test run lasts only a few seconds because no material on Earth can survive that heat for much longer. Yet those few seconds generate data that decides the future of missiles, jets, and even spacecraft. When these tunnels fire up, the noise doesn't sound mechanical. It sounds cosmic, like a star being born in a steel chamber. If you want something more visibly chaotic, meet the industrial metal shredder. These machines don't politely recycle, they eat. Cars, engines, refrigerators, I-beams, doesn't matter. A rotor armed with steel teeth the size of baseball bats grabs entire vehicles and pulls them into a spinning metal maw. A whole car becomes fist-sized chunks in under 20 seconds. The power draw? More than a skyscraper. They run on a mix of violence and electricity. Then there's the industrial robot that laughs at human reaction times. The Delta robot. These lightweight, triangular-armed machines move so fast they have to be enclosed because they'd break human bones on contact. In packaging lines, they pick and place objects at 300 movements per minute, with acceleration forces that would knock out a jet pilot. They're basically mechanical spiders with lightning nerves. And if you want the final boss of mechanical insanity, it's the large-scale forging hammer. These monsters drop multi-ton steel blocks from heights that turn raw metal into precision components in a single, earth-shaking impact. Stand near one and you can feel the shockwave in your bones. Modern versions are controlled with millisecond precision, using servo systems that read metal resistance in real time. Machines like these prove one thing: humanity didn't just master physics. We bent it until it screamed.